The dense inner region is super strange. Here, the central gas that was traced through the UV emissions, which also shows us much denser particles, seems to show us a lot of highly ionized gas, and that's where it seems to be also dramatically enriched in nitrogen. And so most of the extreme nitrogen overabundance is basically in the center, or very close to the center, because we don't actually think this is coming from the black hole. And this tells us that the enrichment was highly localized and very likely involved a central event, possibly inside some kind of a very dense region, with this enrichment not spreading to the bulk of the galaxy, but only happening in a very small area, possibly area that's just a few hundred light years across. And surprisingly, in this area, compared to nitrogen, carbon is not enriched either. So basically both carbon and oxygen seem to be very similar to what we expect from a typical star-forming region, but nitrogen is dramatically enriched. And that means that atypical slow-acting stars or medium-sized AGB stars cannot explain any of this. They cannot explain why this region is so enriched in nitrogen, yet does not have as much carbon or oxygen. So what exactly happened then? Well, right now there is maybe one exotic solution. Here, the evidence from both of these studies and the overall conclusion is that this might involve the hypothetical concept referred to as SMS, supermassive stars. And these are hypothetical stars that are ridiculously massive and possibly similar to population 3 stars. We're not actually entirely sure if they're the same or not, and were very likely formed from pristine hydrogen and helium, representing the leftovers from the Big Bang. But because they lacked heavier elements, which usually limit how massive a star can get, these early conditions allow these stars to form into really massive objects far beyond the typical mass of about 150 solar masses. And so here the model suggests that supermassive stars potentially explain what we're observing. If they have a mass of anywhere from 1,000 to maybe 10,000 or even more solar masses, they would actually create these giant factories producing nitrogen, which would explain why we're seeing this. And so during the primary fusion phase, or the core helium burning, their massive turbulent interiors convert most of the carbon into nitrogen, which then is dispersed throughout the stellar envelope and escape through these very powerful stellar emissions. And critically, based on the models used in these two studies, the extreme nitrogen to oxygen ratio seems to simultaneously match the observations of relatively normal carbon, oxygen, and even neon ratios discovered inside this galaxy. In other words, based on the models, the actual chemical observations seem to match the predicted models. And if confirmed, it would make GS 3073 a crucial galaxy. It's basically a kind of a fossil with a chemical imprint left behind by some of the most massive stars we've ever seen.